Hi, I am Pankaj Bhattacharjee, a computer science engineering student. This is my AI-powered fraud detection system developed for Razorpay AI Builder Internship 2026. The goal of the project is to detect the potentially fraudulent transactions using machine learning and provide an explainable risk decision. The project is structured as an end-to-end machine learning application. The source folder contains pre-processing, feature engineering, model training, and prediction service. The app folder contains the Streamlit interface while the API exposes the prediction services. I also included automated test, training script, and module artifacts. The datasheet contains fraction information including transaction ID, timestamp, customer, terminal, transactions amount, and the fraud level. For these documentations, I generated 8,000 synthetic transactions with approximately 3.15 percentage fraudulent transactions. The dataset is explicitly labeled as a synthetic because it is intent for demonstrations the systems rather than claiming real world fraud detections performance. Raw transactions data transformed into machine learning feature. For example, the system extracts the transactions hour and day, identifies the weekends and night times transactions, detect usually high transactions amount, applies a logarithmic transformations to the amount and calculations the amount of Z score. These engineered features are then used by the machine learning models. The training pipeline evaluating multiple machine learning algorithms, including logistic regressions, decision tree, and random forest and XGBoost when available. The data is divided into training and validation and sets. The validation set is used to select the decisions theirs hold, while the final test set remains untouched until the final evaluation. This prevents the test set from being used to tune the model. The selected model in the final experiment was random forest. Using the validation selected their sold the final untouched test set achieved approximate 96.75% ROC and AUC and 72% recall. Because the dataset is synthetic, this number of demonstrations results rather than the production performance. Now I am demonstrate the prediction workflow. I am entering the sample transactions with an amount $150 and the transactions time is 2 p.m. and on June 15, 2025. Okay. Then access risk and the decision summary is transaction summary is all is given there. Fraud probability 100.00% means 100%. The system convert the transactions into the same engineered features using training and generate a fraud probability. The probability is then compared with the decisions threshold to determine whether the transactions should be considered fraudulent. The system also provides an interactive decision threshold. A lower threshold makes the system more sensitive to the pointer fraud, which can increase the recall but also increase the false positive. A higher threshold is more conservative and can reduce false positives but may miss more fraudulent transactions. This demonstrate that understand by business trades off, not just machine learning. The analytics page provide a model evaluation dashboard. It shows the fraud versus legitimate and transactions distributions, confusion matrix, ROC, precision recall, and curves and comparison between the trained models. This allows an analyst to understand not only the predictions but also overall behavior of the model. On the main technical challenges was the class imbalance because the fraudulent transactions were much less common than legitimate transactions. I addressed this through the validation based thousands turning and experimented with class balancing and approaches. Another challenge is maintaining consistent feature engineering between the training and predictions, which is solved my using the same feature pipeline for both. Overall, the project demonstrated to end-to-end AI fraud detection workflow with machine learning. There's all the optimizations, explainability, API integrations, and interactive dashboards. Thank you.